Hello students and learners, welcome to the Brainbox tutorials. I am your teacher Priyanka and today we will solve specimen paper of I.C.S.E. semester 2 chemistry. Okay, so we will discuss the exam pattern first and then we will solve this paper also. So the maximum marks is 40 and time allowed is 1.5 hours. The paper is divided into two sections. Section A is compulsory, where all the multiple choice questions will be there. 10 questions will be there for 1 mark each. That means section A is of 10 marks. And then from section B, we will have to attempt any 3 questions out of 5 questions given. So section B, 3 questions for 10 marks each, that will make 30 marks. So 30 plus 10, 40 marks paper. Let's start with section A. This is multiple choice questions. So question number 1, part 1. The IUPAC name of ethylene is, guys, the IUPAC name of ethylene is ethene. So option C is correct. Now number 2, carbon to carbon double bond is found in, A2-butylene or 2-butene, we can also say. See, butene means carbon, methane, ethane. See, 4 carbon and then 2, that means if we start from here, so in second number double bond will be there and everyone has single bond to butylene, and then we will have to add the hydrogen in the remaining bonds. So 1, 2, 3, 4 here hydrogen, 1, 2, 3, 1 hydrogen here, 1, 2, 3, 1 hydrogen here and 1, 2, 3 hydrogen here. So this is 2-butylene or 2-butene. Number 3 is fused alumina is reduced to aluminium by electrolytic reduction since number A, alumina is highly stable, number B, alumina is least stable, number C, alumina is not reduced by drying agents, number D, alumina is not reduced by reducing agents. So number A, alumina is highly stable is correct answer. Now number 4, the catalyst preferred in the conversion of sulfur dioxide to sulfur trioxide is number A, finally divide iron, no. Number B, graphite, no. Number C, vanadium pentoxide, yes, this one is correct, vanadium pentoxide. Remember, this equation comes in the preparation of sulfuric acid. Now number 5, substitution reaction is a characteristic property of alcohols, alkane, alkene, alkyne. Now substitution reaction is the property of alkanes. Number 6, the gas evolved when dilute sulfuric acid reacts with iron sulfide. So when sulfuric acid is reacting with iron sulfide, let's see the option. Number A, sulfur dioxide, no. Number B, carbon dioxide, no. Number C, hydrogen sulfide, yes, this is the correct option. Hydrogen sulfide, that is H2S gas. Okay. Now number 7, an acid obtained from concentrated nitric acid on reaction with sulfur. Options are number A, carbonic acid, number B, sulfuric acid, number C, nitric acid, and number D, hydrochloric acid. Here option B, sulfuric acid, will be the correct option. Subpart 8, the hydroxide soluble in excess of ammonium hydroxide is, now number A option is zinc hydroxide and the first option is correct, zinc hydroxide. Number 9, the chemical name of the principal ore of aluminium. Number A, sodium aluminium fluoride, number B, aluminium oxide, number C, hydrated aluminium fluoride, number D, hydrated aluminium oxide. Yes, option D is correct, hydrated aluminium oxide. Now last question of section A, hydrocarbon which is a greenhouse gas. Number A, acetylene, number B, ethylene, number C, ethane, number D, methane. Now methane is the correct option, this is a greenhouse gas. Section B, question number 2, part 1. Define number A, catenation. So the definition of catenation is the property of self-linking of atoms of an element through covalent bonds in order to form straight chains, branch chains and cyclic chains of different sizes is known as catenation. And number B is define alloy. So definition of alloy is a homogeneous mixture of two or more metals or of one or more metals with certain non-metallic elements. Number 2 is name the compound formed when number A, ethene reacts with hydrogen in the presence of a catalyst. Now the product formed will be ethane, right? Its answer is ethane. Remember the equation, see ethene C2H4, it is reacting with hydrogen gas in the presence of a catalyst that is nickel and the temperature is 200 degrees centigrade. So it will make C2H6, that is ethane. Now number B is bauxite reacts with sodium hydroxide. So the product or the compound formed is sodium aluminate. Now we can see the equation here. See bauxite Al2O3.2H2O with sodium hydroxide NaOH will make sodium aluminate, that is NaAlO2 plus water, and now we can balance it. So in balancing, here 2 and here 3 will have to put. Okay, so name the compound, it is sodium aluminate. This is for your practice purpose. You will have to write the name only in the answer. Now number 3, draw the structural diagram of number A propanol, number B ethanoic acid and number C 1,2 dichloroethane. Let's draw the structural diagram of these three. Let us draw these three structural diagrams. First is propanol. So how many carbon? 1, 2, 3. And then because Al is written, that means aldehyde, so CHO should be added. And now the rest of the bonds with hydrogen. This is propanol. Next is ethanoic acid. So 2 carbon. Oic acid, that means carboxylic acid, COOH. So OOH, 1, 2, 3, 4 bonds. Here 1, 2, 3, 4 with H. Next is 1,2 dichloroethane. So ethane, 1,2 dichloro in 1 chlorine, in 2 1 chlorine. Rest hydrogen. And these are the structural diagrams. Subpart 4 is complete and balance the following chemical equations. Number A, C2H6 plus O2, this will make CO2 plus H2O. And now balancing, so 7O2, 2, 6, 4. Number B is C2H2 plus I2. This will make C2H2I2. Number C, NH3 plus HCl. This is easy. Testing of ammonia. It will make NH4Cl and it is already balanced. Question number 3, subpart 1. Identify the anion present in the following compounds. Number A, compound Z, which on reacting with dilute sulfuric acid liberates a gas which has no effect on acidified potassium dichromate but turns lime water milky. So first of all, think about this gas which has no effect on acidified potassium dichromate but turns lime water milky. It is carbon dioxide gas. Now carbon dioxide gas, when it is released, so some compound Z, it is reacting with dilute sulfuric acid. So that compound should have carbonate in it. Otherwise carbon dioxide will not be produced. So anion present is carbonate, or you can write CO3 with valency. Carbonate or bicarbonate, HCO3. Any one of the anion is present. Number B, the solution of compound L on reacting with freshly prepared ferrous sulfate solution followed by addition of few drops of concentrated sulfuric acid to the reactants along the sides of a test tube forms a brown ring at the junction of the two liquids. So this is from brown ring test. So which compound is added with ferrous sulfate and concentrated sulfuric acid, that is HNO3. So the anion present is nitrate, NO3. Moving to number 2, state the following. Part A is the drying agent used in the laboratory preparation of HCl gas. It is concentrated sulfuric acid or H2SO4. But concentrated, remember. Number B, products formed when ammonia is burnt in excess of oxygen. Nitrogen dioxide. This is the last product which is formed, NO2. But you can also give the names of nitric oxide and H2O. Actually, what is the reaction? See, when ammonia, that is NH3, in excess of oxygen 5O2, it is burning. So platinum is used as a catalyst and it is in 800 degrees centigrade. It is put in 800 degrees centigrade temperature. So nitric oxide and water vapor is released. Okay, let's balance it. 4NH3 5O2 will make 6H2O 4 nitric oxide. Then nitric oxide will react with oxygen gas and will form nitrogen dioxide. Okay, balance it. 2N, 2N. Right? Moving over to subpart 3, state the observation for the following when manganese dioxide reacts with concentrated HCl. So when manganese dioxide reacts with concentrated HCl, chlorine gas is evolved. Chlorine gas, but how do we observe this? So chlorine gas is greenish yellow gas. So you can write that greenish yellow gas is evolved. And guys, I have erased the equation there because that is not necessary. That was only for your explanation, for your practice. That is why I have shown that. So because the answers will not fit in the paper, so I have erased that part. Now part B is what do you observe when a glass rod dipped in concentrated HCl acid is brought near ammonia gas? So dense white fumes of ammonium chloride is evolved. So what do you observe? Dense white fumes. Okay, that we will observe. Now see, concentrated sulfuric acid is added to carbon. So when concentrated sulfuric acid is added to carbon, sulfur dioxide is evolved, and sulfur dioxide has a pungent and suffocating smell. So we can write pungent and suffocating odor. Or you can start with a gas with pungent and suffocating odor. That also you can write. Okay, now number 4, write balanced equation for the following conversions. Number A, lead sulfate from lead nitrate and sulfuric acid. So lead nitrate, that is PbNO3 plus sulfuric acid H2SO4, and it is making lead sulfate PbSO4, and the full solution is nitric acid will also be formed. Now we will balance it. Here 2, and it is balanced. Number B, nitrogen trichloride from ammonia. So when ammonia gas reacts with chlorine gas, then nitrogen trichloride, that is NCl3 and HCl are formed. And now we will balance it. 3 HCl, 3 Cl2, and it is balanced. Number C, sodium chloride from sodium sulfite and dilutes hydrochloric acid. Sodium sulfite, that is Na2SO3, dilute hydrochloric acid is HCl, will make sodium chloride, that is NaCl. It will make water and sulfur dioxide gas is evolved. Now let's balance it. 2Na, 2Cl, and it is balanced. Now moving on to question number 4, part 1. State the relevant reason for the following. Number A, a layer of powdered coke is used over the electrolytic mixture in Hall-Herold's process. Now, why a layer of powdered coke is used? There are 2 reasons for it. You will write that because powdered coke reduces heat loss by radiation, and secondly because it prevents the burning of anode. Now next, B is graphite anodes are continuously replaced during the electrolysis of alumina. So for this, the answer will be that the graphite anodes are continuously replaced during the electrolysis of alumina because it gets oxidized by the oxygen evolved at the anode. Now moving over to part 2, name the alloys for the given composition. Number A is magnesium and aluminium. So an alloy made up of magnesium and aluminium is magnesium. Number B, magnesium plus manganese plus aluminium plus copper. This will be duralumin. Okay. Now number 3 is identify the terms for the following. Number A, the experiment which demonstrates high solubility of ammonia gas. The experiment's name is Fountain experiment. So, Fountain experiment. Number B, a method used to collect HCl gas. So, HCl gas is collected by the method upward displacement of air. So, that is the method used, upward displacement of air. Number C, the electrode where reduction takes place. So, reduction takes place at cathode. So, the answer is cathode. Okay, now number 4, complete the table given below. So, there are 3 columns given. First column is name of the process, reactant's name in second column, and acid product formed in the third column. Okay, so part A, reactants are given nitrogen dioxide, water and oxygen. So, which acid will be formed? Nitric acid, that is HNO3. And name of the process is Ostwald process. Ostwald process. Number C, will have to name the process. Oleum plus water, acid produced is produced is sulfuric acid. So the process is contact process. Contact process. Right? Moving on to question number 5, part 1. Write the balanced chemical equation to show the concentration of ore in Bayer's process. Number A, sodium aluminate to aluminum hydroxide. Let's write the equation. Sodium aluminate, that is NaAlO2 plus water will make sodium hydroxide NaOH plus aluminum hydroxide AlOH whole 3. And now we will balance it. So it is already balanced. Now number B, aluminum hydroxide to alumina. So aluminum hydroxide AlOH whole 3 to alumina. So at 1000 degrees centigrade it is decomposed. Alumina Al2O3 is formed and water vapor also will be formed. Now let's balance it. 2, 3 and it is balanced. Now number 2. Select the correct answer from the brackets to complete the following statements. Number A. The catalyst used in the oxidation of ammonia is zinc or platinum. So platinum is used in the oxidation of ammonia. Number B. The product formed when ammonia reacts with oxygen is, we have just done it, nitric oxide or nitrous oxide. It was nitric oxide. In the previous questions, a question was there of ammonia and excess oxygen. Okay, number 3, name the following organic compound. Number A, the compound with 3 carbon atoms whose functional group is a carboxylic acid. So, with 3 carbon atoms, that means meth, eth, prop. So, it will be prop, and because it is a carboxylic acid, so oic acid. So, prop-oic acid, that is propanoic acid. Propanoic acid. Okay. Now number B, the first homologue whose general formula is CnH2n. Alkene has this formula, general formula, and first homologue of alkene is ethene. Okay, number C, the compound formed by complete chlorination of ethine. So the compound will be acetylene tetrachloride. Because see, its formula is C2H2Cl4. So acetylene tetrachloride, 4 chlorine are there. Okay, now moving on to number 4. Answer the following questions related to the laboratory preparation of the hydrogen chloride gas. Question number A is, why is sodium chloride preferred to other metallic chlorides? So the answer to this will be, sodium chloride is preferred to other metallic chlorides because sodium chloride is cheap and it is easily available. Number B, state the temperature required in the preparation. So we see that the temperature should be below 200 degrees centigrade. Number C, write the chemical equation. Chemical equation is sodium chloride NaCl plus H2SO4 below 200 degrees centigrade gives HCl and NaHSO4. HCl, an upward arrow for that, and it is already balanced. Moving on to question number 6. Number 1. Distinguish between the following. Number A is dilute HCl and dilute HNO3 using silver nitrate solution. So when dilute HCl is reacted with silver nitrate solution, then a white precipitate is formed. So white precipitate. And when dilute HNO3 is reacted with silver nitrate solution, no precipitate. No. Now part B, dilute HCl and dilute H2SO4, that is sulfuric acid, using lead nitrate solution. So when dilute HCl reacts with lead nitrate solution, a white precipitate is formed which is soluble. But when dilute H2SO4 reacts with lead nitrate solution, an insoluble salt is formed. So here insoluble salt, and here dilutes HCl, we will write soluble salt. Okay. Now number 2. Give one word for the following statements. Part A. Naturally occurring minerals from which metals are extracted. They are called ores. And number B. Organic compounds having the same molecular formula but different structural formula are called isomers. Now part 3. A, B and C are the chemical properties of sulfuric acid. Number A, oxidizing agent. Number B, dehydrating agent. Number C, non-volatile acid. Now match the following equations 1 to 3 to the above chemical properties of sulfuric acid. So here are the 3 chemical equations given. Let's see. Number 1. KNO3 plus H2SO4 will make KHSO4 plus HNO3. So here the non-volatile property of sulfuric acid is shown. See, a non-volatile acid is producing a volatile one. So this is number C. Number 2, C12H22O11 will make 12C11H2O. So we can see that H2O, that is water, is removed from this particular compound. So part B, here H2SO4 is used as a dehydrating agent. Number 3, S plus H2SO4 will make H2O plus SO2. So here S is converted into SO2, that means oxygen is added to it because of H2SO4. So here H2SO4 is working as an oxidizing agent. So part A is correct, that is oxidizing agent. Now moving on to the last part, number 4. Study and complete the following table. So we can see here a table is given and few parts are missing. We will have to fill those parts. Homologous series are alkane and alkyne. General formula for alkane is given. Alkyne we will have to write, okay, CnH2n-2. Now IUPAC name. So common name is given marsh gas. Marsh gas IUPAC name is methane. And here ethine is given. We will have to write its common name. Common name is acetylene. So acetylene. So with this question we have come to the end of our chemistry semester 2 specimen paper solution. I hope you have liked the solution provided by me, and if you have liked it, then please hit the like button and also share this solution with your friends. Don't forget to subscribe my channel because I will come up with such solutions from time to time. Until I come with the next video, keep preparing, keep practicing for your exams. Bye bye. Jai Hind.